In episode 54 of Mobycast, Jon and Chris teach a primer on DNS and explain exactly what happens when you type a URL into the browser. Welcome to Mobycast, a weekly conversation about cloud-native development, AWS, and building distributed systems. Let's jump right in.
Welcome, Chris. It's another episode of Mobycast.
Hey, John. Good to be back.
Good to talk to you. So what have you been up to this week?
Yeah, I'm recovering from the jet lag from the epic trip down to Brazil last week. So 32 hours of travel each way.
Ouch. Yeah. The humble brag, though. Poor me. I was in Brazil.
Yeah. And it's so ironic though, right? Like 4 days in Brazil and 32 hours on either side of that traveling. So it almost ends up being a wash, right? It's like a one for one. So right, I paid for it.
You did. So me too. I'm trying to recover from being in Brazil. It's kind of funny because that trip motivates me after I see the team and, get excited about our futures, but it also exhausts me. So I come back motivated with no energy to do anything. But here we are. Next week, the motivation is going to really kick in. But one of the things we talked about while we were down there was, we did a lot of lessons with the team. We decided this year to go over some fundamentals because, the better you are with fundamentals at any sport, including software programming, the better you are. So we decided to turn back to some fundamentals and just brush up on some things that, many people might never have really delved into and others not since, college courses kind of thing. So one of the things we talked about a lot was networking. And I think today, we talked about it for a whole day. So we won't do that to you, our listener. Our one listener. We'll keep it short. And we'll do one little piece of the networking overall talk we did today. And this might be the beginning of a series on networking where we get into the fundamentals of networking and then some specifics around networking within AWS, because that's just super fun stuff. So that's the trajectory probably for the next few episodes, unless something major happens that we have to do a special report on, like we did with some of the open source shenanigans that happened recently. So today we'll talk about DNS. What happens when you type in www.kelsis.com? Go ahead and type it in now into your browser.
We'll wait.
Yeah. So what happens? And that's what we're going to cover today. And maybe Chris, you can kind of kick us off and get us started with that answer to that question.
Yeah. I mean, it's so as you mentioned, we had a bunch of technical content training for the team while we were during a retreat in Brazil. And one of those days was all about networking. And as you mentioned, lots of stuff to cover there, but DNS is definitely one of the fundamental pieces. And so kind of just thinking about the idea of what happens when you type in a URL, how does your browser know where to go? What are really the mechanics there that's happening? And it's probably a lot more involved than most people realize. It's pretty interesting. So with that today, we could just kind of walk through that flow to help demystify it a little bit and just give everyone a better understanding of just how does DNS work. And so maybe to just start off with at a high level, so DNS, it's an acronym that stands for Domain Name System. And really DNS was created for us, for people, because, when the internet...
computers don't need it. They're fine without it.
Well, not only do they not need it, but they don't want it, right? It's not,
right.
It's not very efficient. So, when the beginnings of the internet, when networking started happening, right, you have physical cards and network interface cards. At the end of the day, everything with a network interface card ended up having an address and IP addresses, right? So this is called IPv4. So it's a dotted IP address, four components to it. And, everyone's probably obviously seen these things. So, 192.32.33.255, right? Or 232. 255 is actually a special one. We won't use that one.
Yeah.
But, that's the address, right? And so when all this first started, right, that's what people were doing. They were connecting to one of these addresses. And, once there started to be more than a handful of machines on a network, people realized pretty quickly, this does not work, right? I can't remember all these dotted things, or I've put them in a notebook somewhere and just I'm manually keeping track of, oh, that's John's server, or that's Larry's server. or that's Susan's server. So this concept of keeping track of, like, giving these friendly names to these addresses was the start of it. And this was just a simple text file. It's actually, a host file. So it was a kind of like a very small directory in a text file that gave a mapping between a friendly name and the actual address it was. So this allowed folks then to be able to type in that friendly name, so they could type in like John, and that resolved to John's IP address, and likewise Susan's IP address. So that was the beginning of it.
Right, and that host file lived on Unix systems, at least under the /etc/hosts in that file.
And the funny, interesting thing is that it continues to exist today. And not only does it exist today, but as we'll find out, it's actually the first. It's still very much part of the process in the lookup process. So it's still the first link in that chain of events that happens when something goes to resolve a host name to an actual address. And so essentially that's what DNS is, basically the phone book of the internet, right? It's you can go look up something by name and it gives you its address. And this is how, at the end of, computers are figuring out, like, given a friendly name, what machine do I connect to? Where do I send my packets to?
Right, exactly. And so the host file doesn't really scale. You can't have all of the IP addresses on the internet in your host file and keep them up to date with where, what names they go with. So people had to come up with another way. And, one of the things I love about DNS is that the way that they came up with was a protocol that anybody could participate in. It wasn't a company that came along and said, we're going to handle routing of names on the internet and just send us your money and we'll send you the IP addresses when you give us a name. That's kind of how we've ended up. And that's kind of where we are now, in a way, because that's how it was designed. And anybody can still play. So we still have a protocol. Anybody can still stand up a DNS server. And I think that's the next part of this journey that we have to talk about. What's a DNS server and what do they do?
Right. Yeah. So just to touch on that, like, again, it is kind of interesting. DNS is one of those fundamental early protocols that comprise the backbone of the internet. So this has been around for, since the early days, the inception, right? So it's just like things like mail, SMTP, the kind of like the core protocols, these things have been around a while. They have their own limitations. They have issues with trust and security. And we might talk a little bit about that as we discuss this. But yeah, so DNS, at the end of the day, client server architecture. So you have DNS servers that are managing the records that they're responsible for. And then you have clients or resolvers that query those servers to get the records. So it's basically just making a query saying, hey, this is the address this is the name I'm looking for. Do you have its address? And it's either going to respond back like, yes, it does have it, or it will perhaps refer them to some other server it's walking down a chain of hierarchy. So there's this kind of like parent-child relationship as you move through the dots of the URL, right? So you can think of DNS as a hierarchy where, at the very top you have like root, and then you have the top level domains like .com or .net or .org, and then underneath that you have the next level domains, so things like yahoo.com or kelsis.com type thing. So there's a hierarchy there. But at the end of the day, you have the servers that are managing the files and answering these requests, and then you have the clients of the resolvers themselves that are issuing these queries to make lookups.
A fun thing that I like to think about is just how both DNS and IP addresses are sort of that hierarchical thing. And they both enable some scalability. They both enable it so that only a few servers out there need to know and be responsible for all the top level domains. And then beyond that, we can use other servers to deal with the next level. And then beyond that, more and more servers can play in this tell me the IP address for this name game. And that's pretty cool. It's like the scalability is built into the protocol. And with IP addresses too, we won't talk about how IP routing works, but it's the same basic concept. The IP address is basically a map that tells a computer how to get from here to there. And that's why you don't have to hand somebody an IP address and a map of how to get there. It's part of the IP address. So it's pretty cool that they both work in a way that makes them scalable and usable just at the protocol level.
Yeah, absolutely. It's almost Darwinian, right? Like if they didn't work, we wouldn't be here talking about these things, right? Yep. So it's like, by virtue of the fact that they do work and they are scalable, they've lived on and it still works this way. And the reason why it has had so much longevity, which is pretty amazing if you think about it, right? Like when DNS was first created, like, did they really think like there's going to be billions of devices that are going to be on this network and just millions and millions of host names? Maybe, but like, it's probably still a lot bigger than they thought.
Yeah. I agree. Okay, so let's talk a little bit more about DNS servers and what they do and what they have inside of them.
Right. Yeah. So DNS servers are, again, they exist to manage the names that they own, right? Where they're the authoritative source for, and they can host multiple zones. And so you can think of a zone as different levels of a URL. So you can have like a zone file for like api.kelsus.com maybe, and then you might have another one for another domain that Kelsus has and whatnot. So it's a way of segmenting up your namespace. So, but these DNS servers, they can, at the end of they register with other name servers to say for which domains or which of these zones they are the authoritative source for. And that's one of the ways that at the end of that these requests end up getting routed to them, as knowing that this is where they need to go to make that lookup to find that name.
Right. So there's a few servers out there that live inside AWS that are saying to the world right now today, hey, I've got Kelsus.com. I've got that one. You want to know where that goes? You ask me, I'll tell you.
Yep, absolutely. Yeah. So for every domain out there, there's some registration with it to say like, yes, I am the authoritative source, the name server for this particular domain, whether you're using AWS Route 53 or you're using something like GoDaddy or DNS, whatever DNS. If you're rolling your own or standing up your own server, they would all work the same way.
Hey there, this is Rich. Please pardon this quick interruption. We recently passed an internal milestone of 30,000 listens, and I wanted to take a moment to thank you for the support. I was also hoping to encourage you to head on over to iTunes to leave us a review. Positive feedback and constructive criticism are both incredibly important to us. So give us an idea of how we're doing, and we'll promise to keep publishing new episodes every week. Okay, let's dive back in.
And so for each one of these zones, you're going to have a list of records, and there's various different types of DNS records. And so you have things like regular just IP addresses, if you will. So, given a name, what's its IP address that I can connect to? And so that's one type of record. That's called an A record. You can also have kind of redirects, pseudonyms for records. So you can you can give something a friendly name. So sometimes you might have a less than friendly domain DNS name for something, and you want to alias it to something nicer or easier to remember. And so you can have those kinds of records in there, where those are CNAME records that are basically just aliases for something else.
A nice thing about those, just to interject, is just that they stay what they are. So if you have a CNAME and you decide you want api.kelsus.com to point to, 12345.aws. Amazon.com/something, lots of gobbledygook text. When that CNAME is typed into a browser, the browser keeps the CNAME. It doesn't switch over to the alias. It's not transparent. So that's a nice feature of CNAME.
Yeah, and other types of records are for like routing mail. So you have mail transport records, MX records, right? So this tells clients that are sending mail or they need to route mail to say, well, where should this mail be delivered to? There's records in DNS for dealing with that. So at the end of that, DNS, very diverse, very capable, lots of flexibility. It's really deals with all the traffic on the internet. Again, given a name, what's the actual, at the end of the day, what is the IP address that this needs to go to? And that's what it's doing. Another thing that's pretty important to talk about too is just like, because this is used constantly, right? Like whenever you're doing, like anytime you're making any kind of network request or whatnot, right? You're probably doing a DNS lookup to say, like, hey, given this host name, what is the IP address? So in order to increase performance, lots of caching is involved. And again, caching is really good here because for the most part, these addresses are not changing. very frequently, like even if you have something that you're using something like DH, they're just not changing that frequently. So caching comes into play heavily. And so you can set TTL records, so time to live values on these records, which give guidance onto how long intermediaries are allowed to cache this. So TTLs end up becoming pretty important where when you are specifying if you are setting up DNS and you have some host names that you're adding and whatnot, something just to consider that if it's going to be relatively stable and you don't expect to change it very often, then you can set it to a higher TTL. But if it's something that, this gets more into just like if you're building out a service and maybe you're going to be changing it from one environment to another one, and just realize that when you update your DNS server, the updates are not going to propagate immediately. It's going to be based upon whatever your TTL was. So if you have a high TTL, like say it's 1 day, you're probably going to be unpleasantly surprised to find out that it takes a full day before everyone is now pointing to the new server because of that caching. So
right, and with TTLs, the thing I like to think about is that this TTLs and caching are why DNS propagation is different for different people and in different locations. So you change a domain name and you update it maybe on GoDaddy, and then if you're unfortunate and using GoDaddy, and then you're like, okay, I made the change. Oh, yep, I'm seeing it. Yep, there's the change, and your friend who's on the other side of the world is like, I'm still not seeing it. It just could be because they are hitting a DNS server that cached that address more recently than the one that you are using. So it's always good to assume that some DNS server out there just moments ago cached the address that you're about to change. So you're going to have to wait the entire TTL before everybody's up to date.
Exactly. Yeah. So it is definitely one of those things where if you ever do work with DNS and making entries and changing them, like this is something that you become intimately familiar with and you get bitten by it. Mm-hmm. Or, you start running into this, well, it works for me, but not for me. Or I see the new page or I don't see the new page type thing. So it's just definitely something to take into account. And again, if you're planning on changing something, make sure you set it to a low TTL until you're stable, and then you can increase it to a higher TTL. So and strike that right balance between the flexibility of change versus performance and minimizing your lookups.
Right. So this is already turning out to be more, complicated to describe than I had expected. It's DNS. It's easy. It's quick protocol. And we still have a lot of things to talk about here. Let's see. I think the next thing that we were going to talk about is, did you want to go more into resolvers, Chris, or did you want to talk about the flow, like sort of the story of, a day in the life of a request from a browser?
Mm-hmm. No, I mean, at the end of the day, the clients or resolvers, if you will, they're basically just, hey, I need to talk to some name server. So there's a way of configuring your client, your resolver, to know what name server to go talk to, and it's just issuing a query. Say, hey, this is the name I'm looking for. Give me a record back. Sometimes, if the server does have it, it's done. If it doesn't have it, it's going to tell it like where's the child that you should go talk to and do it. And just so pretty simple from a client standpoint. There's many different types of clients and resolvers. There's standalone. So there's some really useful like command line tools like dig and NSLOOKUP. Your browsers are obviously have resolvers, and some of those are based upon OS level code. Some have their own custom resolvers. Same thing goes with, server-side software like Nginx as well. So, they have, everything, just anything that's making connections, right, has to do DNS lookup. So,
and I think that the thing that almost goes without saying, but I'm just going to make it really explicit, is that when you type in www.google.com into your browser, and you've never done that before, it's not got a cached IP address or anything that it's ready to use. It's got to go look up that name using, the DNS. You can almost think of it as a microservice, a distributed microservice that gives you back that name. It has to do that whole request before it even starts to load the Google page. So it's like everything you ever do is two requests and not just one. And I think that I think that's easy to forget because you're like, oh, I'm going to Google, and you just imagine the network traffic. It's like it's going from my computer to Google, getting stuff and coming back. No. It's going to some DNS servers and then coming back, and then going to Google and then coming back. And I just had to say that really explicitly in case it wasn't clear from what we were talking about already.
Yeah, and probably even more specific, it's not just two requests, like that DNS is actually potentially many requests, multiple requests, right? So
how long do they take? Sometimes it can take like 60 milliseconds, 80 milliseconds.
Yeah, I mean, it just depends on your network. It depends on the name servers and how much traffic they're getting. So it could be, milliseconds. It could be sometimes, seconds. It's just, making, it's just like anything else. It's making a network request, over the internet. So there's very real latency there. So I think the kind of like the real takeaway here is like, there's a lot going on in order for DNS to work. And there's, when you do type in that address at the top of your browser bar, you type in google.com, there's underneath the covers, there are quite a few steps happening before that page appears inside your browser.
Right. And you mentioned a tool. I think it's worth it for anybody who's never done that before, just to go, if you have a Mac, which most of you do, I'm just guessing, just go to the terminal and type dig space plus trace, TRACE space, and then a domain name. It could be www.kelsis.com, or it could be mobycast.fm, or it could be google.com or whatever. And then just look at what comes out. It comes out in steps, and there's a lot of information there, and it's worth checking out because it starts to uncover the complexity that Chris is talking about.
Yeah. So and that's what that plus trace option does, is that's normally that the intermediate lookups is hidden from you, and so you just see the final results. And when you put in that plus trace, it's actually showing you how resolution happens. So it starts at the very top, going to the root servers of the internet. From there, it's then going to the TLD servers for whatever TLD it is for your name. So the TLD would be like that. If it is it .com, is it .net, .org? There's a whole separate set of servers that just manage just for those. And then from there, it can then go and find out, okay, what's the authoritative server for this particular address you're looking for? And so when you have that plus trace option on there, you'll see that. And it just makes it very, very explicit, very clear what's happening there, that there is this hierarchy of DNS servers, and it's traversing that to go and make it more narrow in scope to find the actual information that it's looking for.
One of the things that I used to wonder about at the beginning of my career when I thought about DNS is if an A record points to an IP address, and an IP address is just a single machine, and you've got a really big service, like at the time maybe it was Yahoo, how can that single machine handle all that traffic? And I honestly don't know when it became possible to have multiple A record answers. And I'm not sure it was possible at that point 20 years ago. But now for sure it is possible. So it could be that it's been all along, you've been able to say, oh, there's 4 or 5 different A record answers. So these 4 or 5 different IP addresses can be round robin, and they can handle all the traffic. And it's sort of like a DNS style load balancing. But I don't know if that's always been the case. Do you happen to know, Chris?
It's been around for a while. It's been at least since the early 90s, and perhaps even before then. So having this multi-answer DNS records, it's definitely been around for quite some time. And then, of course, now, we can use things that coupled with things like load balancers. So you can now have a single domain name that at the end of the day may be serviced by hundreds of machines behind it.
Right. So I think we probably need to wrap up here. And what we've shortchanged in this conversation is security, which kind of funny. It's kind of ironic that's the part that we didn't get to yet. And it's also a little bit tough because you, our lovely audience, have kind of shown us that your favorite episodes are not the security ones. So maybe we'll try to tuck in some of the security stuff into a future episode, but not do an entire episode on DNS security, because I don't know that would be what everybody wants. But for what it's worth, there's a bunch of cool stuff in DNS security that we totally want to talk about at some point soon here.
Yeah, and it may be kind of boring or not as interesting, but it's really important, because at the end of the day, DNS, like we talked about, it does things like routing of mail. And so if you're able to spoof or be a man in the middle and change the MX record for your mail server for some domain, this means it's pretty easy for someone to hijack your mail. So whenever anyone sends you a mail, instead of that mail being forwarded to the server that hosts your mailbox, it goes to some rogue mailbox. And you would never know, like, other than people will be like, "Hey, why aren't you answering my emails?" You're like,
right.
I didn't get anything.
So maybe that's how we can get people to listen to the DNS security episode coming up. Well, it'll be titled something like "How to Hack DNS and Get Free Stuff from Amazon for Life."
There you go.
All right. Well, thanks everyone for listening, and thanks, Chris, for explaining this so well. And I'll talk to you next week.
All right. See ya. Bye.
Well, dear listener, you made it to the end. We appreciate your time and invite you to continue the conversation with us online. This episode, along with show notes and other valuable resources, is available at mobycast.fm/54. If you have any questions or additional insights, we encourage you to leave us a comment there. Thank you, and we'll see you again next week.